So let's go to exercise 2A. Exercise 2A, question number 7 and question number 12. So exercise 2A, question number 7 and question number 12. Okay. Um, Now, whenever the function is divided into two parts for even and odd, so don't use the method which I have taught you in the previous session for one to one and all two. Okay. So we'll simply draw the diagram for such type of problems even and odd, and we will conclude. Okay, so this is set A which has X, set B which has Y. Okay, uh, so rather set A has N, set A has N, and set B is Y. Y is f of N. Okay, and f of N is divided into two parts, N plus 1 and N minus 1. So when to use N plus 1 when the function is even, and when to use N minus 1, use N minus 1 and when the function is odd. Now, if you take a look at both X and Y, the mapping is from whole number to whole number. Okay, so this is X or rather N, and this is Y. Y is nothing but f of N. In the textbook, there is a printing error. It should be f of N, not f of X. Okay. Now see guys, let's list down the whole numbers where N is a part of all whole numbers. So that is 0, 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. This will go on and on. Y also belongs to all whole numbers 0, 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. Okay. Now when N is 1, when N is 0, the first value of N is 0. Okay. So 0 being even, will use N plus 1. This is for even, and N minus 1, this is for odd. So 0 plus 1 is 1. So 0 is mapped to 1. Okay. Now when it is 1, when N is 1, N is odd. So 1 minus 1 is 0. Use the odd function. Right? Okay. I hope you are getting it. When N is 2, what is f of N or rather Y? When N is 2, 2 will be mapped to what? Can someone tell me please? 2 will be mapped to what? 3, correct. 2 will be mapped to 3. And what about 3? When N is 3, you'll use the odd function. 3 minus 1, which is 2. Okay. So 4 will be mapped to 5. And 5 will be mapped to 4. 6 to 7. 7 to 6. Likewise, this will go till infinity. Right? Now you tell me, looking at this particular diagram, looking at the ordered pairs, is this one-to-one mapping? Is this one-to-one mapping? First, we are checking for one-to-one. Are many objects in the first set pointing towards a single object? That is not the case. Fine. So it's one-to-one. Looking at the diagram, I think it's quite evident it's one-to-one. Fine. Now you tell me guys, is it onto? For onto, you need to take a look at the codomain. The codomain is the entire set B. It's the codomain. Are all objects related over here? Are all objects related? As in, are the images of some pre-image? The answer is yes. The answer is yes. So each and every object is related over here. Hence, this is a bijective function. You can write the statements in your own words. It's one-to-one because there is a one-to-one mapping. It's one-to-one because there is a one-to-one mapping. And all objects in the codomain are related. or all objects in the codomain have a specific pre-image. Okay. Therefore, it's onto. So guys, can you tell me whether this is a bijective function or not? Boys, I should hear from you. Is it a bijective function? Yes, very well. So for even and odd, I would recommend that you draw a diagram and solve. Okay. Question number 12. So natural numbers to natural numbers is the mapping. So this time it is n and y. Y is nothing but f of n. Okay. So A has n, B has y. Y is nothing but f of n, and f of n is written in two different parts. N square and n plus 1. N square when n is odd, and n plus 1, 2n plus 1 it is even. Okay. Now natural numbers should start with 1. It's from natural to natural, so both the sets will have a natural number. Now when n is 1, so 1 square is 1. When n is 2, when n is 2, 2 into 2, 4 plus 1, 2 will be mapped to 9. When n is 3, when n is 3, 3 will be mapped to what? 3 will be mapped to what? Udar boys, can you tell me? 3 will be mapped to what? Waiting for your answer. 3 will be used over here as 3 square, which is 9. 3 also will be mapped to 9. Okay. So now this many examples are enough for us to proceed with our discussion. Okay. Okay. Now when n is 2, when n is 2, f of n is equal to 2n plus 1. So 2 into 2 plus 1. Oh, sorry. Yeah. I'm really sorry. Just a second. Yeah. When n is 2, it is mapped to 5. I just did a calculation error. Okay. Okay. Now when n is 4, when n is 4, when n is 3, it will be mapped to 9. When n is 4, it will be towards 9. Okay. So this many examples are enough for us to proceed ahead. I just did an error. For 2, I used 9. That was not the case. 2 should be mapped to 5. Okay. Yeah. So first point of discussion, injective, that is 1 to 1. So is it 1 to 1? Yes or no? Is it 1 to 1? Yes or no? Why no? Because 3 and 4 are mapped to a single element, that is 9. So it's many to 1. Okay, you can give that reason as the answer. It's not injective because 3 and 4 are having the same image. Okay. Right? And is it onto? Is it onto? In the entire codomain, there are so many objects which are not related. They are not the images of any other object. So definitely it's not onto. So for even and odd, I would rather suggest is don't use the method which I have taught you in the previous class. Okay, just for even and odd. Okay, you can give examples and to support your answer why it is not one to one, why it is not on to, or why it is one to one and why it is on to. Okay, is that clear, everyone? That was your question number 12. We'll be solving question number 8 right now. We'll be solving question number 8. The mapping is from real numbers to real numbers. So this is x and this is y. If you recollect the previous class, f of x is equal to cos x. F of x is nothing but y. Step number 1, to prove one to one. You know this procedure very well. F of x1 is equal to cos x1. F of x2 is equal to cos x2. Equate this. F of x1 is equal to f of x2. Copy till here. I'll just wait. Yeah. So f of x1 is equal to f of x2. We equate this. We get this. Cos x1 is equal to cos x2. Okay. Now there are two cases over here. Try and understand how. Cos x1 is equal to plus cos x2. I'm writing plus because this has a plus sign over here. Okay. Now cos is positive in which quadrants? Cos is positive in which quadrants? It is the first and the fourth quadrant. It is the first and the fourth quadrant. So there will be two cases. One solution for the first quadrant and one solution for the fourth quadrant. So for the first quadrant, I can just write cos x1 is equal to cos x2. Therefore, x1 is equal to x2. Okay. Now for the fourth quadrant, okay. So this is 360 and we are going back in the clockwise direction. So cos x1 is equal to cos 360 minus x2. Cos 360 minus x2. See guys, cos 360 minus x2. 360 is over here, minus in the clockwise. In this quadrant, your cos is positive. X-axis. Cos remains cos plus cos x2. Okay. So for the fourth quadrant, the solution is this. Cos x1 is equal to 360 minus cos 360 minus x2. Because cos 360 minus x2 is cos x2. Therefore, x1 is equal to 360 minus x2. So here, x1 is not equal to x2. Okay, we cannot say for sure that x1 is equal to x2 because x1 plus x2 is equal to 360. We didn't get this x1 equal to x2. We got x1 plus x2 is equal to 360. So here this is failing. Even if the first case is passing, the second case is failing. Okay, therefore not injective or one to one. Therefore not one to one. Okay, please copy this. If you have any doubts, then please ask. Everybody is clear with this particular case? Okay, now see, this cos x2 is plus cos x2. Okay, it literally means one and the same. Okay, now cos is positive in the first as well as fourth quadrant. In the first as well as fourth quadrant, right? Now first quadrant we can keep it same. Cos x1 is equal to cos x2. So x1 is equal to x2. But then in the fourth quadrant, this plus cos x2, I'm writing it as cos 360 minus x2. Because 360 is over here and cos should remain cos. Hence, I am selecting 360 and not 270. Okay. So see, 360 is over here. Minus angle decreases in the clockwise direction. That's how we get to the fourth quadrant. Okay. So cos 360 minus x2, fourth quadrant cos is positive. And since it is x-axis, cos remains cos. So it's plus cos x2. Plus cos x2. Okay. So this plus cos x2 is written as cos 360 minus x2. Now compare x1 is equal to 360 minus x2. Fine. So x1 is not equal to x2. Hence it is not one-to-one, not injective. Second part of the problem. Step 2. To prove onto. Just a second. To prove onto. Okay. So f of x is equal to cos x. So y is equal to cos x. Y is equal to cos x. Therefore, this is y in terms of x. We'll get x in terms of y. So what is x? Can you tell me? What is x? X is cos inverse of y. X is cos inverse of y. Cos goes on the other side, it becomes cos inverse. Okay. Right. Now this is inverse trigonometric function. Now let us understand this. Okay. So this is y, this is x. Okay. The function is cos x. And the mapping is from real numbers to real numbers. Okay. Fine. Cos inverse of y. Now, if you remember the domain and range of inverse trigonometric function, cos inverse y will give you an angle. Cos inverse y will give you an angle. So what is the valid angle for cos inverse y? It lies between 0 to 180. It lies between 0 to 180. Do you recollect this? I have sent a PDF on the group. Cos inverse y will give you an angle. That angle will lie between 0 to 180. And y is the value? The value will lie between -1 to 1. The value cos inverse y. The y value will lie between -1 to 1. Okay. Now see, I'm just drawing this diagram. -1 dot dot dot. There will be 0 somewhere over here and 1. These are all real numbers. Okay. -1 to 1. So for -1, there will be a pre-image. For all these values, there will be a pre-image. For all these values, there will be a pre-image. Let me ask you a very simple question now. If the value is 1.5, 2, or maybe 100, or -1.5, -2, or -100, will there be a pre-image? Will there be a pre-image for these values? Will there be a pre-image for these values? Yeah, please answer. Why is the value? I've explained that to you. Why is the value? Okay. And cos inverse y is the angle. And values of y will always range between -1 to 1 for cos inverse. So from -1 to 1, from -1 to 1, everything will have a pre-image. But then what about the rest of the values, the rest of the real numbers, which are not between -1 to 1 and including -1 and 1? Will all these real numbers, remaining real values, will they have a pre-image? No, that is not the case. They will not have a pre-image. And since these values are not having a pre-image, this is not onto. It's into. Because all values should have a pre-image, right? Okay. So now I'll just give a short note over here. You may just write it down. So once you write x is equal to cos inverse y, write down y lies between -1 to 1. Y lies between -1 to 1. There will be pre-images only for, there will be pre-images only for y lying between -1 to 1. Only for y lying between -1 to 1. The other real values of y, the other real values of y, which are not in between, which are not in between -1 to 1, like this you write. The other real values of y, which are not in between -1 to 1, will not have a pre-image. Will not have a pre-image. Will not have a pre-image. Therefore, all objects in the domain, all objects in the codomain, all objects in the codomain will not have a, will not have a pre-image. Only few values will have a pre-image. The values which are ranging from -1 to 1. Okay. Therefore, not onto. Therefore, not onto. Therefore, not onto. We'll take the same problem for sine. It's not given in the textbook, but then we'll just try to understand for sine, just as an additional example. Okay. So let's go to that. This is an extra problem. Okay. This is x. This is y, real number to real number. F of x is equal to sine x. Okay. Step 1. F of x1 sine x1, f of x2 sine x2, f of x1 equal to f of x2. We are proving 1 to 1. To prove 1 to 1. Extra problem. F of x1 is equal to f of x2. Therefore, Sin x1 is equal to sin x2. Therefore, sin x1 is equal to plus sin x2. So when is sign positive? When is sign positive? The first and the second quadrant. For the first quadrant, you keep it same. Sin x1 is equal to sin x2. Therefore, x1 equal to x2. This is for the first quadrant. Now, for the second quadrant, try to understand. Sin x1, okay, now plus sin x2. So we'll stay on 180 over here because we have to go to the second quadrant. So I'll write sin 180 minus x2. Guys, just tell me, is sin 180 minus x2 plus sin x2? Yes or no? Yes or no? Is sin 180 minus x2 plus sin x2? Come on, please revert. Boys. Yeah. Therefore, x1 is equal to 180 minus x2. Therefore, we can say x1 not equal to x2. So the second case fails. Therefore, this is not 1 to 1. Therefore, this is not 1 to 1. Therefore, this is not 1 to 1. Second case, I'm starting. Step 2. To prove onto. Of course, it is when it is not onto, it is into. Okay, so y is equal to sin x this time. F of x is y. So x is equal to sin inverse y. Okay. Now sin inverse y will give you an angle. Sin inverse y will always lie between minus pi by 2 to pi by 2. This I've given you in ITF, domain and range table. So sin inverse y will always give you an angle. But then what about y? Y is a value. So what is y? What is y? So if you take a look at the PDF, the value will be only between minus 1 and 1. Value will be only between minus 1 and 1. In the PDF, this will be x and this will be y. It will be reversed. In the PDF, it will be reversed. But then meaning same. Meaning is same. So y lies between minus 1 and 1. Okay. Now guys, please tell me, are the nodes given in the previous problem applicable over here or not? For onto. Will the explanation be the same as that of the previous problem? Yes, everyone. Waiting for your reward. Hello, hello, hello. Okay, so the explanation will be same, right? So this is x and this is y. Y are the values between minus 1 and 1. So only for minus 1 and 1, only between minus and 1 and 1, all the real numbers will have a pre-image. Okay, the other real numbers will not have a pre-image. The other real numbers will not have a pre-image. So it's not onto. So you can copy the notes given in the previous problems. So this is also not onto. Okay. Yeah. Should I go to the next concept? Should I go to the next concept? Yes or no? Fine. So I'll just erase this. Yeah. See, f of x is a function of x. This is called as inverse of a function. Inverse of a function. So f inverse of x exists if and only if f of x is bijective. If and only if f of x is bijective. So just make this note. F inverse of x is existing if and only if f of x is bijective. Okay. So see, if the question is to prove that whether the inverse of a function existing or not. If they're asking you prove that whether the inverse of a function exists or not, what you will prove? What you will prove? We'll just prove that the function is bijective or not. If a function is one to one onto, if it is bijective, then only f inverse x exists or inverse of a function exists. Okay. Yeah. Now see, exercise B is not there for you. We'll go to exercise 2C. Question number 1, sub question 1. Now f of x is 2x plus 3. They are asking you f inverse of x. This is called as f inverse of x, inverse of a function. So y is equal to 2x plus 3. This is y in terms of x. We'll write down x in terms of y. Y minus 3 is equal to 2x. Therefore, x is equal to y minus 3 upon 2. Therefore, x is equal to y minus 3 upon 2. Okay. So y in terms of x in terms of y. So f inverse of x, just focus on this part, x in terms of y. Replace this y with x. Replace this y with x. So x minus 3 upon 2. X minus 3 upon 2. Okay. Yes, guys. Any doubts? Any doubts? Fine. Let's go to the fourth problem. Question number 4. Here you'll understand better. F of x is equal to 4 minus x minus 7 cube raised to 1 by 5. Cube raised to 1 by 5. They are saying it's a real invertible function. They're asking f inverse of x. Read the question in the textbook, you'll come to know. So this is y, and then this y is y in terms of x. We'll write x in terms of y. Now, first of all, this 1 by 5, I have to eliminate. So 1 by 5 will become 5 on the other side. It's indices, basic indices. Okay. So 4 minus x minus 7 the whole cube. Therefore, x minus 7 the whole cube is equal to 4 minus y raised to 5. Now we have to eliminate this 3. How to eliminate this 3? How to eliminate this 3? This 3 sent on the other side will be what? In the power, what should I write? In the power, what should I write? Cube root or 1 by 3, correct. So x minus 7 is equal to y minus, sorry, what was that? 4 minus y by 5. 4 minus y raised to 5. Cube root is 1 by 3. Therefore, x is equal to 7 plus 4 minus y raised to 5 raised to 1 by 3. This is x in terms of y. This is x in terms of y. So step number 1 is to find out x in terms of y. So f inverse of x, wherever there is y over here, wherever there is y, replace it with what? Replace it with what? Replace that y with anyone? X. Replace that y with x. Okay. So this is your f inverse of x. Yes, just share a feedback whether you have understood this or not. Have you understood this, guys? Okay. Let's solve question number 8. Let us solve question number 8. Yeah. So this time we need to prove it is invertible, and then in the end we need to find out the inverse. So mapping is for real number to real number. This is x and this is y. Okay. F of x is equal to 4x plus 3. Step number 1. To prove 1 to 1. F of x1, 4x1 plus 3. F of x2, 4x2 plus 3. Okay. Equate both. F of x1 equal to f of x2. Therefore, 4x1 plus 3, 4x2 plus 3. 4x1 is equal to 4x2. Therefore, x1 equal to x2. Therefore, 1 to 1. Or it is injective. Or it is injective. Step number 2. Y is equal to f of x, and f of x is what? 4x plus 3. Y in terms of x, we'll write x in terms of y. Y minus 3 is equal to 4x. So x is equal to Hello, hello, hello. Guys, am I audible? The connection was lost. Am I audible, guys? Please tell me. Okay. So we have proved that it was one to one. This was just the last part. Okay. So we'll prove it is on to. Okay. So step two. Step two. Y is equal to 4x plus 3. Y in terms of x and x in terms of y. Y minus 3 is equal to 4x as x is equal to y minus 3 by 4. X is equal to y minus 3 by 4. Right? Fine. So we got x is equal to y minus 3 by 4. Now let us understand what is x and y. X is a real number and y is a real number in question number 8. So for any real value of y, will there be a real value of x? Will there be a real value of x? Yes, because you put any real number over there in place of y. Real number minus 3 upon 4 will give you a real value. So x is real. Okay. So you may write down for any real value of y, for any real value of y, there will be a real value of x. There will be a real value of x. Okay. Therefore, all objects in the codomain, therefore, all objects in the codomain, all objects in the codomain will have a pre-image. Will have a pre-image. So is it on to, guys? Is it on to? Yes or no? Is it on to? Waiting for your answer. It's on to. So this is one to one and on to. So is it bijective? Just reply, please revert. If it is one to one and on to, is it bijective? Yes. Okay. Yeah. Now since it is bijective, does inverse exist? Does inverse exist? The answer is yes. Inverse will exist. Inverse of a function will exist if and only if and only if what a function is bijective. Therefore, 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 f inverse of x is equal to x minus 3 upon 4. Over here, replace y with x minus 3 upon 4. So that completes your topic of functions. Okay. Bye. Thank you.